Today we are going to see about the decision trees. Under tree and rule models, we are going to see decision trees, learning decision trees, ranking and probability estimation trees, regression trees, clustering trees, learning ordered rule list, learning unordered rule list, and descriptive rule learning, association rule mining, and first order rule learning. So decision trees are of a type of supervised machine learning where the data is continuously split according to a certain parameter, and it is also a tree structured classifier where internal nodes represent the features of a data set, branches represent the decision rules, and each leaf node represents the outcome. Let's see how many types of decision trees are there and what are the types of decision trees. We are having categorical variable decision trees, that is nothing but the decision tree which has a categorical targeted value, then it is called a categorical variable decision tree. And coming to the continuous variable decision tree, it is a decision tree which has a continuous target variable, then it will be called as continuous variable decision trees. Let's see how the decision tree looks. First we'll be having the root node followed by the parent node, child nodes, and the last node we'll be calling it as a leaf node. Coming to the root node, it is nothing but it starts from the decision tree where it starts. It represents the entire data sets which further gets divided into two or more homogeneous sets. And leaf node to the final output node, and the tree cannot be segregated further after getting a leaf node. So splitting is the process where dividing the decision tree, that is root node, into subnodes according to the given conditions. And coming to the branch or subtree, a tree which is formed by splitting the tree is called subtree. And pruning is the process of removing the unwanted branches from the tree. It is very much essential in the decision tree. And also coming to the parent or the child node, the root node of the tree is called the parent node, and other nodes are called as child nodes. Let's see the example of the decision tree. Suppose if there is a candidate who has a job offer and wants to decide whether he should accept the offer or not. So to solve this problem, the decision tree starts with the root node, that is the salary attribute by ASM, and the root node splits further into the next decision node, that is distance from the office, and one leaf node based on the corresponding labels. The next decision node further gets split into one decision node, that is cap facility, and one leaf node. Finally, the decision node splits into two leaf nodes, accepted offers and declined offers. So let's see, you can see the diagram as if the salary is between $50,000 to $80,000, and if he lives near to the home, that is office is near to the home, then also if there is a cap facility available, then the offer will be accepted. If the salary is between $50,000 to $80,000, and if he is not having the salary between $50,000 to $80,000, the offer will be declined. If so, if has the salary between $50,000 to $80,000 and his office is if office is not near home, then the offer will be declined. But if the office is near to the home and cap facility is not available, then it will be also the offer will be declined. So this is an example of the decision tree. Coming to the learning decision trees, our goal is to build a decision tree to classify examples as positive or negative instance of a constant using supervised learning from a training set. So just to follow the diagram to know about it, decision tree is a tree where each non-leaf node has associated with it an attribute as a feature, and each leaf node has associated with it a classification, and each arc has associated with it one of the possible values of the attribute at the node from where the arc is directed. So generalization is allowed if there is if there are more than two classes. For example, sell, hold, and buy, as you can see it in the diagram. This is example for decision tree induced partition. If the color is green and the size is big, it is considered as negative, and if the color is green and the size is small, it is considered as positive, and color is red, it is considered as positive. But if the color is blue but the shape is square and the size is big, we'll be considering it as negative. And if the color is blue and shape is round, it is considered as positive. In case if the shape is also blue and the color is also blue and shape is also square but the size is small, then it will be considered as a positive. Now the regression tree. Regression tree is nothing but the decision trees where the target variable can take continuous values. That is, typically real numbers are called regression trees, as you can see it in the diagram. Then coming to the probability estimation trees, here we will generalize the classification trees in that they assign class probability distributions instead of class labels to examples that are to be classified. See, as you can see the T diagram for the toss of a coin, that is there are two branches, that is called head and tail, and if the probability of each branch is written on the branch and the outcome is written at the end of the branch. If the probability is 0.5, it is considered as head, and if the probability is 0.5, it is considered as tail. According to the diagram, tosses of a coin is a predictor using a tree diagram. Then coming to the rule based classifier, that is, here we will be classifying records by using a collection of if then rules. That is condition, we will be considering it as y, where if condition is a conjunction of attributes and y is a class label. So LHS is nothing but the rule antecedent or precondition, and RHS is nothing but rule consequent. And here we'll be having the formula R is equal to R1, R2 and RK up to. And let's see the example of classification tree. If the blood type is form and also if it lays X, then it will be considered as birds. If the taxable income is like less than 50,000 and refund is also S, then we will be classifying it as no. Then coming to the next example, rule-based classifier for vertebrate classification problem. This is the problem for vertebrate classification. If it doesn't give birth and also it can fly, we will be considering it birds. This all will be considered using the tabular column. And coming to the next one, if the bird, it will not give birth but it will live in water, it means it considered as fishes. If it gives birth but its blood type is warm, then it is considered as mammals. And if it does not give birth but it cannot fly, then it is considered as reptiles. And if it live in water sometimes, then it is considered as amphibians. So we can classify using rule based classifier with the tabular column. Coming to from decision trees to rules, that is, they will be giving a set of decision trees, they will be giving the diagram, and we have to write the rules for the diagram. For this example, we shall write the rules. That is, if the refund is S, then class is considered to be no, and refund is no, and also marital status is single or divorced, then taxable income is also is less than 80,000, then the class is said to be no. And if a refund is no and marital status is single or divorced, and also taxable income is greater than 80,000, then the class is considered to be S. And if refund is no but marital status is married, then class is said to be no. So we can easily write the classification rules using this decision trees. Next, coming to the application of rule-based classifier, a rule OR covers a record X if the attributes of the record satisfy the condition of the rule. That is, rule OR is nothing but it's said to be triggered or fired whenever it covers a given record. For example, if the birth is not given but it can fly, then it considered to be a birds, as we have already seen the example. So likewise, if rule 1 covers a hawk, that is bird, if the same one if covers a rule R1, then we can consider it as also a bird. And if rule 3 covers the grizzly bear in the second row, then it is also considered to be a mammal. So that is all for today.